today we are going through a lesson that makes a lot of sense if you understand what's going on. Don't overthink it. Okay, if you put it back in this terms, we're going to be pretty good. Okay, so we were talking with Max, and Max said that at 2 years old, so here's 2 on my graph right here, Max was 3 feet tall. Boom, 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 boom. Oh no, your legs don't touch the ground. Oh, you got a really small head and really little arm. I don't know. That's not the best picture I've ever drawn. All right, that's Max. Max said it's 17, so here's 17. You are 6 feet tall. I'm much happier because you have a face now. Was Max ever 5 feet tall? Yes, we can guarantee that at some point Max was 5 feet tall. Why? How do I know that I had to be 5 feet tall at some point? Since growth is continuous. Meaning, in other words, he didn't just randomly change from 4 feet to 5 feet overnight. It was a continuous growth. Okay? Max's height takes on every value between 3 feet and 6 feet. It means he had to reach every height. Like, we wrote it out in a really weird way, but it means he had to hit every height between 3 feet and 6 feet. Okay? We could talk about it more calculus-based. Here's the calculus definition. Y equals f of x. So you have some function. It's got to be continuous on the interval. Then your y value is going to take on every number between your ending point and your starting point. We could talk about it that way. This way makes a little bit more sense, I hope. Okay? That is the idea. That is intermediate value theorem. We had to be 5 feet tall. Now Max is 100 years old. He is 6 foot. Was Max ever 6'1"? Maybe. Do we know for sure? No, we don't know. But all we know for sure is that I was everything in between. He might have had a little growth spurt and then didn't drink enough milk in life and shrunk. Okay, but that still would be a continuous idea. Okay, so we are going to not allow that to affect us here. All right, here we go. So we've gotten this function, x squared minus 4. We're on the interval from -1 to 3. We could just graph that. Let's not, so we don't get confused. All right, if we take -1, we plug it in. We would get -3. If I take 3 and plug it in, 3 squared would be 9. I get 5. So at -1, I am -3. At 3, I get 5 right there. IVT guarantees which of the following must be true. So is there some C value that when I find the Y, when I figure out what this equation is equal to, do I have to get 1.5 for something on that interval? Do I have to go through this line? Yeah, I have to be 1.5. IVT guarantees that because it's in between my 2 endpoints. Does my Y value have to be 4.8 between my 2 endpoints? Yeah, 4.8 is right here. There is no way to go from there to there if it's continuous, and it is because it's a parabola. It has to go through those 2 values. Is it guaranteed that my Y value has to be equal to -3.5? Nah, that does not have to be true. It is true. Okay, think about that. It's a parabola. Okay, it's going to go down like this. It goes down to -4, but it doesn't have to be true. And that's all we care about with IVT, what has to be true as we set it up. Make sense? On free response, this could be a free response question on the AP exam. You would need to state it correctly. There are 5 specific things that you have to state when we talk about intermediate value theorem. Okay, we've talked about each of them already. Talk with your neighbor and brainstorm your way through those 5 things. Remember back to first semester, see what you got. Let's brainstorm as you frantically look through your folders to try to find out what it is. What's one that we need? Morgan, what do you need? You got to say it's continuous. If we don't state continuity, then it doesn't matter. Okay? Continuous is the most important one. Otherwise, you can jump around and skip values. You've got to state it's continuous. I would state it really early on, or otherwise you'll forget it. Aaron, what's that? What else? it has to talk about the interval. Okay, so from when to when is it true? All right, so for Max, it was from 2 years old to 17 years old. That was his interval. Those are the X values. All right, so like when does it start and when does it stop? What else, Evelyn? The maximum and the minimum, in other words, are endpoints. What numbers do I know that I'm going to be in between? Those are my Y values for this setup. Whatever my biggest Y value, my smallest Y value, I'm going to stay in between those two things. What else? I need two more, Max. You got to say IVT. Like this whole thing is based on the fact that we've got this theorem called intermediate value theorem. Think about the words intermediate value. Intermediate means in between. Value means values. You're in between values. All right, don't overthink that. Okay, and then number 5, I heard somebody talking about it. Megan, do you remember it? I think you were talking. No? Oh, no. Say again? It takes on every value. Sure. You got to say the value. I was trying to switch colors. The value is between the endpoints. Whatever you're looking for has to be between the endpoints, and you have to state that. And we stated it before using a nice little inequality. Everybody ready? Those are the 5 things you need. If you don't have one of those 5 things, you will not get full credit. You have to state them all. They all make sense, right? Growth is continuous. 2 to 17 years old. He was 3 feet. He was 6 feet. We started with the thing, IVT, and we know that 5 feet's in between there. All of those things you would say if you were describing height to somebody else. You just got to make sure you put them in this setup. Use intermediate value theorem to show that f of x takes on the number 9 somewhere on the interval from 1 to 2. The first thing we need to do is find our endpoints. Take 1, take 2, plug them in, see what you get. Show me with your fingers, what'd you get when you plugged in 1? Show me with your fingers, what did you get when you plugged in 2? You get 10. Be careful, because if you don't get the right values, then the whole thing would be wrong. Okay, but we got that right there. Now we're going to state this, okay? We like to, all we need is those 5 things. They don't have to be in any particular order. I used to like have students tell them to me the first time through, and it got really ugly. So we're going to try to make a decent sentence. We'll see how it works. All right, so here we go. First thing we're going to state is continuity. Since f of x, you can't say it, you can't say the function, you have to call it by name. Whatever it's described as, write that down. Since f of x is continuous. There's my first one. The next thing we're going to state is the endpoints. We already stated them here, but I'm just going to write them in my problem. So since f is continuous and f of 1 equals 2 and f of 2 equals 10. Next thing we're going to state is IVT. IVT guarantees. We're going to be very emphatic. IVT is telling us this has to be true. IVT guarantees f of x must be 9. We're just restating there. Okay, we're just saying intermediate value theorem guarantees this must be 9 on the interval from 1 to 2. It's just stating that interval that we just had there on the interval from 1 to 2. And then the last thing we got to say is why. How do we know that's true? Because f of 1 is less than 9 is less than f of 2. We are stating whatever our starting value is, 9 is in between that starting value and that ending value. We know what f of 1 and f of 2 is. We stated them up there. Okay. All 5 things need to be shown. We said continuous. We said the endpoints. We said IVT. We said the interval. We said that our number was in between our endpoints. Make sense on how we did that. Try it again on example 2. You're trying it. Try not to flip back and forth on your paper. There's a reason why I put it on the back side. So you had to actually use your brain. See if you can do that. We start off and we find the ordered pairs. I take 0, I plug them in. I take 1, I plug them in. Now we're going to write our sentence. Let's see how we did. Megan K., what did you start off with? Wonderful. Since f of x is continuous, you got to start off by stating that it's continuous. If you don't state that, you're not getting anything else. So we got to state that it's continuous. Alexis, what else did you say? And f of 0 is -1, and f of 1 is 2. Wonderful. She's got to state those endpoints. We don't state those endpoints, we don't know what we're going to be between. Cool. We've got that from there. Brooklyn, what did you put next? IVT. Guarantees. We got to talk about IVT. It's the whole reason why we're doing the problem is to talk about IVT, so you better state it. IVT guarantees. I'm going to go ahead and rewrite what it's saying. IVT guarantees f of x has a 0. And if you're doing it right, you should know the next part as well. Joey, what do I need next? Yeah, it says it right there in the problem. If you just restate that, you're getting a lot. You're getting 2 out of 3. IVT guarantees f of x has a 0 on the interval from 0 to 1. That's 1, 2, 3, 4 things, and then I got one last thing to do. Grace, what else do I need to state here? Because f of 0 is less than 0, because it's -1, and that's less than f of 1. Perfect. We got the 5 things we need. Continuous, endpoints, IVT, the interval, and then the value that I have is in between my endpoints. Questions on 2. Not too bad. They're not always that easy. Sometimes they'll give us something a little bit more like this. This is from a previous year's AP exam. The function f and g are differentiable. Okay, that is what our whole next chapter is about. It's about finding derivatives. Right now, we don't know what that means. But for now, when you see that word differentiable, just think of the word continuous. Okay, so differentiable for us, we see that it means continuous. For all numbers, and g is strictly increasing. So that means g is just going up. You can look at these g values. You can see they are continuing to go up. The function h is defined by this guy right there. Explain why there must be a value for r such that h of r is -5. Talk with your neighbor. See what you can do there. Go. Look here. Show me with your fingers. What'd you find for h of 1? H of 1. What'd you get? When you plug in 1, you should have gotten 3. Let's see why. If I take 1 and I plug it in here, that's g of 1. Here's my g. G of 1 is 2. Then what do I need to do with that 2? Plug it into f. It's f of 2. So f of 2 is 9. So then it is 9 minus 6. That value is 3. You've got to be able to use that table. We're going to use that table all of the time. It is something we're going to do a ton of. You got to be good with it. Okay, so keeping that same setup. Next one, h of 3. Show me with your fingers. What did you find for h of 3? Good. H of 3 is -7. We are taking 3 and plugging it in. So we're starting off with g of 3. G at 3 is 4. Then we're going to find f of 4 minus 6. F of 4 is -1 minus 6. That's where I'm getting -7 from. Now that we have those values, you should be able to explain why there has to be some place where h of r is equal to -5. Write that right now if you haven't. Go. See how you did. That should be what your answer is, that thing right there. Looking through that, again, there are 5 elements. Let's see if we can find all those 5 elements. Abby, what's something that I had to state? Got to stay continuous. I got it. Sarah, what else? IVT. We got to say IVT. What else here, Evelyn? The interval. Yep. 1 to 3. Good. Sadie, what else? The y's. I had to state my endpoints. Good. And then the last thing I had to put up here was what, Dolly? Yep, that I'm in between those 2 values. Good. Questions on how we did that? Number 4 is a multiple choice question that would apply into this. We don't know what B means yet, so don't worry about B, but read the other ones and see if you can figure out which one it is, A, C, D, or E. When in doubt, graph it out. See what you can do. Good. Let's look. Here's my graph. When in doubt, I'm going to graph it out. Does it tell me anything that f of 0 has to go through the point 0, 0? No. That's garbage. Don't let that be an answer to us here. That doesn't make any sense. We don't care about the derivative one yet. Does f of x, does my y value have to be less than or equal to -1 and less than and equal to 3 for everywhere between -3 and 6. Here's -3 and 6. Does it mean that I have to stay in between those lines? It could, but that's not what IVT guarantees. It doesn't mean that I have to stay in between the lines. The graph can do whatever it wants. Okay, it doesn't state that it has to be in between the lines. It's not C. Letter D says f of, or let's go to, yeah, that's fine. F of C is equal to 1. Here's 1 right here. F of C, that's the y value. Do I have to be equal to 1 at least once between -3 and 6? Do I have to go through that line? Yeah, because I'm continuous. There's no way to connect those dots without going through that line if I'm continuous. Oh, just plain. That's the right answer. Letter E says I got to be 0 between -1 and 3. -1 and 3 shortened it down. I don't have to be. I could have done this and then been fine and not crossed that line at that during that time. Make sense on that one? All right. Our test is on Thursday. The test is Thursday. Let's talk about the AP exam really quickly, just so we understand what's happening. So this is the test you'll take. Okay, in May, you'll take the test. It'll look like this. You will have 30 multiple choice non-calc questions. You got 60 minutes to do that. And then you will have 15 multiple choice calculator questions. You have 45 minutes to do that. That gives you a total of 45 multiple choice questions. They take each of those and multiply by 1.2. Why do they multiply by 1.2? Because it gets you to 54 points. Okay? That's the first half of the test. And once you do that, the second half of the test, there are 2 free response calculator questions. You get 15 minutes per question, so that would get you 30 minutes through that. And then you would take 4 free response non-calculator questions. Each free response question is 9 points. There's 6 of them. 6 times 9 give me 54. 54 plus 54 tells me the test is out of 108 points. So it is evenly balanced that the multiple choice is worth as much as the free response. This part is the easier part. This part is the harder part in general. Just be aware of that. So far, we've really just done multiple choice. What we did today will lead us into free response. We will practice that on Monday. Okay, but here's what our tests are going to look like in here. Okay, each test is going to be 9 multiple choice questions and 9 free response questions. Okay, where it's a total of 9 points there. Okay, we don't do the multiply with multiple choice, but it's a total of 18 points. So 18 points. If you missed like 5 of them, you got a C. If you missed 7 of them, you would fail. All right, and it's pretty easy to miss some of these questions. We will curve it some, but you need to make sure you're ready to go because it's not a ton of points. There's only 18 possible points. You can go one way or the other pretty quickly. Make sense on how that's going to work? Good. You guys want homework? No, me neither. So let's do some practice in class. We're going to do 4 problems on the board. If we do those, we won't give any homework. Okay? Talk with your neighbor. Answer this question. Eliza tries to use intermediate value theorem to justify her answer. See if what she gave was sufficient. Talk with the person next to you. We'll go over it here in a minute. Go. Thumbs up if she's good. Thumbs down if she's bad. We're getting some thumbs up for Eliza. Your complaints were mostly that she didn't write very well. But other than that, we believe they have all the necessary elements. Let's see if that's true. Make sure we have them all. Caroline, what's something I have to put in to prove IVT? Got to be continuous. Continuous. Cool. We got that. What is something else that I have to say here, Morgan? Got to say the interval. Does she do that? Yeah, somewhere between 0 and 2 down there at the bottom. What's something else I have to put here, Jack? Got to say the y values. We've got that. This h of 0 is 0 and h of 2 is 1.82. We got that. Matthew, what else do I need? IVT. Yep. Intermediate value theorem. I need one more thing. What is the last thing that I've got to state here? Anybody? It's between. Do we say that? Yep. They said it weirdly. She said it in words, but it works. It's in between. Is it super pretty? No, but if we got the answer, that's all we care about. If you have those 5 things, you're going to be complete. Let's try it again. Okay. Here's another description. Someone else trying to justify using that table. See if they did it correctly. Thumbs up, we're good. Thumbs down, we're bad. Oh, so close here. We got the endpoints. We've got the in-between. We've got IVT. We've got the interval. What is the one thing they forgot? Continuous. If you don't state that it's continuous, nothing else matters. You got to state it's continuous. You need all 5 things in order to be good there. Next one. See what you got. Thumbs up. We can use intermediate value theorem. Thumbs down, we can't. Why not? Why is this one not working as well as we would like it to? Somebody raise your hand and tell me. What do you think, Megan?
Because when x is 0, it's 230, and when x is 5, it's 175, and 150
150
doesn't fall.
does not fall in that interval. What could we have changed to make it actually work for what we have set up here, Henry? Yeah, instead of 0, we could have said x is between -3 and 5. Then, if I got 110 and 175, oh yeah, 150 falls in between. Okay, or we could have chose 0 and 17, or whatever else we could have done, but it has to fall in between our interval. Questions on what we did today? Did it come